Right now, your electric car is doing something it can't actually do. It's telling you exactly how much battery is left. 62%. 41. 18. But here's the strange part. No electric car can measure how much charge is inside its battery. There's no sensor for it, no fuel float, no gauge that peaks inside. That number on your dashboard? It's a guess. A guess made by software running one of the most elegant estimation problems in modern engineering. And most of the time, it's right within a couple percent. The question is, how? To understand how a car can know something it can't measure, we have to look inside software most drivers don't even realize exists. Welcome to Curious Human, where we uncover the hidden engineering behind the technology shaping our world. Let's start with what feels obvious. Your phone shows a battery percentage. Your laptop does too. So surely the car just reads it, right? Here's the problem. Charge isn't a thing you can see. Think about a tank of gas. You can drop a float in it. The float rises and falls with the fuel. Easy. But a battery doesn't hold a liquid you can float on. It holds energy in a chemical reaction. Electrons packed into materials you can't look at, can't weigh, and can't drain a little to check. So engineers are stuck with a brutal question. How do you measure something you fundamentally cannot see? And it gets harder, because a car's battery isn't one battery. A typical EV pack is hundreds, sometimes thousands, of individual cells wired together. Every single one of those cells can be at a slightly different level, so the car isn't estimating one number. It's tracking a whole population of cells, all drifting, all aging, all lying a little. That's the mystery, and the solution is genuinely beautiful. But to see it, we need our first clue. The first idea engineers tried is the obvious one: voltage. A battery's voltage drops as it drains, so just measure the voltage and read off the charge. Simple. Except voltage is a liar. Here's the twist nobody expects. In many modern EV batteries, the ones using lithium iron phosphate, or LFP, the voltage barely changes across most of the battery's range. Look at this curve. From roughly 20% all the way to 80%, the voltage is nearly a straight line. It hardly moves. So imagine you measure the voltage and it reads 3.3 volts. What's the charge? It could be 26%. It could be 58%. It could be anything in between. That single reading covers nearly a third of the entire battery. Voltage alone is useless here. And it's worse than that, because batteries have something almost human: memory. If you just finish charging, the voltage sits a little high. If you just finish driving, it sits a little low. Same amount of charge, two different voltages. Engineers call this hysteresis. The battery literally remembers what it was just doing. So voltage can't be trusted. That's clue number one. And it forces engineers toward a completely different idea. If you can't read the level directly, you do the next best thing. You count. Every time energy flows out of the battery, you measure the current and add it up. Every time energy flows back in while charging, you subtract. Keep a running tally. This is called coulomb counting, literally counting the charge, electron by electron. And for a while, it works beautifully. It's fast, it's direct, and short-term it's very accurate. But there's a catch. And it's the kind of catch that ruins everything slowly. Every measurement has a tiny error. And because you're adding measurements up, the errors add up too. Minute by minute, the tally drifts away from reality. After a few days, your perfect counter is quietly wrong. So now engineers have two flawed tools: voltage, which is stable but lies in the middle, and counting, which is accurate but drifts over time. And here's the insight that ties it all together. What if each tool's strength covers the other's weakness? Counting is great moment to moment. Voltage is great when the car's been resting, so you fuse them. You let the counter run, and every time the battery gets a clean, quiet moment, you use voltage to snap the estimate back to reality. The algorithm that does this fusion has a name, and it's not from the car world at all. It's called a Kalman filter. The same family of math that helped guide the Apollo missions to the moon. Think about that. The number on your dashboard is running the intellectual descendant of spacecraft navigation, just to tell you it's at 47%. So the problem's solved, right? Not quite, because we've been talking about one cell. Remember, there are thousands. And a battery pack has a cruel rule. It's only as strong as its weakest cell. If one cell runs empty before the others, the car has to stop pulling power or risk damaging that cell. So even if every other cell has plenty left, one weak link caps the entire battery. Engineers fight this with something called cell balancing. The system constantly watches every cell and gently evens them out. There are two ways to do it. The simple way just burns off the extra energy from the fullest cells as heat. It's cheap, but you're literally throwing energy away. The clever way moves that energy from the strong cells into the weak ones. Nothing wasted. But it costs more, and it's more complex. So automakers choose cheap and simple, or efficient and expensive. That trade-off is sitting in your car right now. And here's a did you know that surprises almost everyone. 0% isn't actually empty, and 100% isn't actually full. Engineers deliberately hide a buffer at the top and bottom, because charging all the way full, or draining bone dry, wears it out much faster. So the car keeps a secret reserve you never see, protecting the battery from you and from itself. The battery you own is bigger than the range you actually see. Now for the part that changes how you'll see your own car. That 100% on your dashboard? It's shrinking every single year. As a battery ages, its cells hold a little less energy. Chemistry wears down. So the car quietly remeasures how big the battery really is and relabels the new, smaller maximum as 100%. Your full battery today holds less than it did the day you bought it. The car just never tells you. This is called state of health. And figuring it out is its own hard problem because real drivers never behave like a lab. We rarely charge to full. We rarely run to empty. We drive in heat and cold and everything between. So modern systems increasingly use machine learning, watching how your battery behaves over thousands of ordinary drives, to estimate its true health without ever needing a perfect full cycle. And this finally explains something you've probably been told and never understood. Why your car's manual says to occasionally charge all the way to 100%. It's not really about filling the battery. It's about giving the software a known landmark. A full charge is one of the few moments the car can be certain where the true top is. So it uses that moment to reset its estimate and erase the accumulated drift. You're not just charging, you're recalibrating the gauge. And there's one more layer most people never separate out. The battery percentage and the range estimate, the miles remaining, are two completely different guesses. The percentage is about what's in the tank. The range is a prediction about the future, how far that charge will take you. And the future depends on everything. Your speed, the hills, the heater. In freezing weather, an EV can lose around 30% of its range, partly because cold slows the chemistry, and partly because heating the cabin drains the same battery that moves the car. That's why the range number seems to jump around in winter. It's not broken. It's re-guessing constantly as the world changes around it. So let's go back to that number on your dashboard. 62%. It was never a measurement. It's the output of a battery model, counting electrons, corrected by voltage whenever the car rests, filtered through spacecraft-grade math. Balanced across thousands of cells, hiding a secret reserve, and quietly adjusting as the whole pack ages. It's not a gauge, it's a guess. But it's one of the most disciplined, self-correcting guesses in anything you own. And once you know that, you can't unsee it. Every EV on the road is quietly solving the impossible thousands of times a second, just to give you a number you barely glance at. And this is only getting smarter. The next generation of battery software won't just estimate what's left, it'll predict how you'll drive, learn your patterns, and even forecast how your battery will age years into the future. The humble battery icon is turning into something closer to a living model of your car's chemistry. A tiny scientist, riding along, guessing brilliantly, every second of every drive. But batteries are just one place this hidden estimation lives. The same kind of invisible software is quietly running your phone, your laptop, even the grid that powers your whole city, all guessing at things they can't directly see. So here's what I'll leave you with. If your car can't truly measure its own battery, and it's still right within a couple percent, how much of the technology you trust every day is running on brilliant, invisible guesswork? Tell me what you think in the comments. I read them. Curious human.